So picking up from where we left off last time, we now have a character that can walk around the world. The next thing we're going to tackle is dealing with this wonky control rotation that doesn't care about our orientation, and a few of these other glaring issues like how it keeps walking without us giving it input. Yeah, so let's get started. Alright, let's start by going into our base character blueprint. Let's go to the viewport and let's add a few things that help us out here. Let's add a scene. Call this control helper. Let's add another scene. Let's call this scene yaw. One more, and let's call this scene pitch. We're going to use these to control our control rotation without the need of using quaternions. I'm going to add one more arrow just to show us where we're looking. I'm going to make sure that's not hidden in game. And then I'm going to scale it up a little bit to 2.5. And we need to move that up here, but let's move these other things first. Control helper, move that down 90. So it's at the feet. And then scene yaw. Let's move that back up to the face. Pitch we can leave where it is. And looking rotation is good where it is. So it is shown in game. Actually, let's bring this down just a little bit. That's good. So let's test that out. All right, that's what we would expect. Let's go into our player input graph under camera input, and let's disable this add control pitch input. This is changing our control rotation. We're going to control it through these scene components instead, so we don't need this anymore. Back in our tick graph, let's drag off of here. I'm going to make a node. And then let's start adding our movement for our control rotation. Let's take the scene yaw, add relative rotation. I'm going to split this, and we'll take our value for looking left and right. If you don't have this, and you might not if you didn't start from the ALS base project, you can go to project settings and then input. Right here. So let's take this and add that into yaw. And if you want, you can multiply this, or you might want to clamp it as well to some amount. But for the sake of this video, we're going to leave it. Similarly, we're going to do the same thing for pitch. Except we're going to set, not add. Set relative, set relative rotation. And let's split this one. And from the pitch, we're going to do combine. Oh, sorry, let me do this from the other direction. From here, let's get relative rotation. And then combine rotators. And then now we want our get look up and down. Similarly with this one, if you don't have it, you can add it into your input. So we want to add on to the pitch. And then add those together. Oh, I'm overlooking one thing. We also don't want it to fall over. Like if we look up and we look down, we don't want it to continue to roll beyond looking directly down at your feet or looking straight up. So to stop that from happening, we can clamp it. Sorry, clamp angle. So minimum negative 89, minimum 89. If you go exactly to 90, it can sometimes fall over the edge, and then it'll keep rotating in the opposite direction that you want. So that's, you just pull it back a degree to make sure it doesn't happen. And now with this, we can set our control rotation. Sorry, we need to use get player controller first. Now we can set control rotation. So looking, get world rotation, and then connect that. So this one sets our yaw, this sets our pitch, and then it takes those values and it sets our control rotation from that. Hopefully that makes sense. It's because it's locking those into just one direction locally. So let's try that. Actually, real quick, let's make this world a little bit bigger. So let's say 10. And grab our character, move it up. All right, let's test this. All right, my controls are inverted for pitch. So I'm gonna take this value. I'm gonna multiply that by -1. You could also change it in your input settings, but for now that works. All right, so up and down, left to right. So that works, but right now I have the system's fighting me. It's trying to move in a different direction. I think ALS base thinks it's falling around the edge. Let's think, what could that be? Let's go in the forward right vector. That could be. Let's take our scene yaw, yeah, scene yaw, get forward vector. So this would be our correct forward vector. Same thing for the right vector. I think that it will solve some of it. Yeah, that's better, but still doing this weird thing. All right, let's go into our rotation settings. Sorry, rotation system functions. Actually, let's search. Pretty sure something is setting the actor rotation, so set actor rotation. This one. There's one here, and then there's one here. Let's think this one. Let's change this. So let's try disconnecting it. See what happens. All right, so it's staying in the direction we need it to. Okay, so this is going to turn the character moving, like if you look to the left or the right 90 degrees or more, this will eventually rotate the character in that direction. But right now what's happening is this yaw is locked onto the character. So anytime the character rotates, it's rotating this. So when we look to the left 90 degrees, and then the character rotates to 90 degrees, this is also now moving another 90 degrees, and so it just keeps trying to catch up to that 90 degrees, but it can't. So we need to, when we rotate our character in yaw, we need to move this in the opposite direction. Which means we need to do, let's see, an actor, yeah, add actor local, yeah, local rotation. And then the scene yaw needs a local rotation as well in the opposite direction. So this is just going to be, yeah, this is just going to be around Z, I believe. So let's split both of these. And we'll input to both of these, but there'll be some value, and then this one will be whatever that value is, but the opposite. And then this value is essentially going to be this, but we need to convert it. This is good. Yeah, actually this is all fine, except for these two. These will need to convert. So I'm gonna plug this yacht into here. This is effectively the same thing as we're doing here, except we're going to convert these. You'll see what I mean in a second. Yeah, actually, let's create this. Let's create these as functions. It'll make our life easier because we're going to do this a bunch of times. So convert to local rotator. And let me show you some things that make life pretty easy. Get actor transform. And then off of this, inverse rotation. And then the opposite of this, which is transform rotation. And similarly, there's the same concept for both for rotators, for location, and for vectors, like a normal vector. So if you type inverse in here, you can see direction, location, rotation. This direction is like a normal. And what this is doing, the inverse transform rotation, is converting it from a world space rotation into a local rotation in respect to this transform. And similarly, but the opposite, transform rotation is taking our local space rotation and transforming it into a world space. So we could do quaternion math, but honestly, I think for most of us that gets a little bit confusing at times. So this is a little bit easier. So anytime we need to, for example, move if we need to rotate something respective to our character. So if I need to yaw 90 degrees, but I don't care where on the planet our character is, and I need to yaw 90 degrees to the left, I can first take whatever our actor, I can get actor rotation, and then I could convert this into local space and then combine, and I could 90 degrees left or right, I forget, and then I could convert it back. So this is adding locally and then convert it back, and this would work, and no gimbal lock. We wouldn't have to worry about that unless you do some crazy stuff here, but this makes life a lot easier than trying to convert or sorry, not convert, but do all this math in using quaternions. Of course, that example is a little bit pointless because we could just do what we did earlier and do add actor local rotation, but we don't have that tool for everything. So just to make life easier, we're going to do this all in a function called convert to local rotator. We'll use our get actor transform and then our inverse. We'll input there. Let's call this one, this is our world rotation. And then we need an output rotator. And this is going to now be in local space. I hope that explanation helps. Sorry if it didn't. You can ask questions. And let's do the same thing, but go in the opposite direction. And oh, sorry, let's convert this to peer as well. So convert to world rotator. nope, sorry. Get actor transform, and then transform rotator. So yeah, okay, input is local, and then convert it to world. Oop, that did not change. Local, make it a peer function, and plug that in. Now we don't have to think about this, we can just say, hey, I want in local space or I want in world space, and that's all there is to that. Where were we? Smooth. Yeah, okay. So both of these need to convert to local space. So let's drag that up and make another copy of that. And I think that should work. So as we rotate the actor, or should say as we turn the actor based on our target rotation, yeah. So whatever amount we turn our actor, we will do the opposite to the add local rotation for the yaw. I'm sorry, I hope I'm not confusing anybody. Okay, so that didn't completely work. I think I know why. I think if we go into update grounded rotation, there's our target rotation is being set in here. This is the function that's actually calling it when we're moving it. This is what we just modified. But when we're not moving, when we're still, it's not calling that. It's so not moving, it's going through here, it's adding actor world rotation, and then it's setting the target. So it should work, what we just did, it should work for when we're moving, but when we're not moving, we're turning, we're just pivoting, then it's going to add actor world rotation, but this is still not getting that opposite turn. So I think we're going to need to do more than just add the offset, but yeah, let's go ahead and try this. Actually, yeah, we will, because this is world. And we have to make sure we're only rotating along our local Y. Actually, yeah, we gotta do this differently. So let's see, we're gonna get rotation amount. It's greater than some small value, true, then rotate. Okay, yeah, that's fine. We're gonna scale. I guess that's frames per second. 30 frames a second, something here. Scaled by time. Yeah, that's fine. And then we're gonna add to world rotation. That's where it's not fine. Okay. So let's get our scene yaw. Add relative rotation. And then do this, I think. Yeah, that should be right. Plug into there. And then we need to turn the actor, but add actor local rotation like we did before. And then, yeah. And then we can set our target rotation to wherever we are at that point. This is fine. Let's hope this works. Yeah, there we go. Cool. So running is working, minus the weird feet. Okay, that seems to work. All right, so that fixes the camera stuff for the most part. And it explains some of the quaternion, or I should say avoiding quaternion stuff. I hope that made sense. If it doesn't, feel free to ask questions and I'll try to clarify that a bit. Next, I think the next thing that makes sense is probably covering some of the line tracing for the feet, because as we run forward, the foot IK is no longer tracing towards the planet. Like as we get towards the side, it's starting to trace tangent to the world, which is clearly a problem, and feet start doing really weird things. I think that's the next biggest issue that should probably be covered. All right, thanks for watching.